Questions about the quiz, the homework, any other homework?
I have a question on the homework.
Okay.
The last two problems, 40 and 41.
Oh. You mean this? I think a lot of people have. Yeah, I mean, this is the stretch your mind problem. So you have to, I guess I'll just put this up here and do it again. You have to kind of fudge a little here. Maybe it'd be better to do it on the overhead. So what we have is, what does that look like? What function does it most look like that we've dealt with? Anyone? I'm sorry? Cotangent. Yeah, remember the tangent would kind of be up this way, and the cotangent is kind of flipped. Now, I'm just guessing here. You know, if you got out a ruler, maybe you'd give a little better number. But I think this is about 20 degrees here between the y-axis and the asymptote. And then we have 180, 360. It kind of goes through here. We have 540, and the asymptote goes again about that same distance inwards from 540. So let's just start with something simple. What's the period here? It's 540 degrees. Right? So let's just keep that 540 degrees. Now, there's something here we didn't talk about. We're going to, you know, which I think is important, something I didn't mention, but for the sine and cosine, we had the formula that P is equal to 2 pi.
Can you lower that, please?
Oh, yes.
No, there we go.
Well, the absolute value is B. And this is in radians, of course. This could be 360 on the top of 40 degrees. But that's the case because the period of sine and cosine are 2 pi. But this tangent that we're dealing with here, it has a period of only 1 pi. So the equivalent formula is going to be P equals pi, or 180 degrees, over B. So plugging in P here, we get B is 180 over 540, which is 1/3. So I'm going to do something down here. We're going to start and say, all right, so f of x is equal to a cotangent of b, which is now 1/3 x minus c, which we don't, well, we're going to talk about c, and then plus d. All right, so the next thing is, if this is the cotangent, it's kind of off a little, right? So how much is it off? Well, I'm guessing about 20 degrees to the left. So what goes in this, you know, C here? I think I did it wrong before when I was in too much of a hurry. Should be x plus 20, shouldn't it? Want to come and get your it's negative 20 degrees that we want to move, but minus 20 degrees is going to be plus 20 degrees. Okay, so I'm making some progress here. Now, we want to know what the excuse me. We want to know what D is, right? We can sort of see that this thing is pushed up a little bit. somebody eyeballed it and said it's about 1, but I'm going to try and give you a little better way of thinking of that. So between 540 and minus 20 is kind of a midpoint here in the middle of the cotangent. So where would that be? So it would be 540 minus 20 is 520 divided by 2, which would be 260. Well, 270 would be right between 360 and 180, so about 20 off of that. Right. At that point, this is now between here and here. That's our D. Now you have to, take a look at the original diagram they give you here, and I don't want to write on the book here, but it's about there. And if you look over, it's somewhere between 0 and 2, and it looks like it's about 1. So, because they're not giving you exact numbers here, that seems like a pretty good guess. So, where does our D go? It goes over here. At this point, now we need to know is what is A? What is A? So, if there's one point on the graph that we can find, then we ought to be able to plug that in, and we ought to be able to figure out what A is. And as I look at this, it really seems like they intended to say at 0, this function is 6. So, let's say 6 equals A cotangent 1/3, well, x is 0, so that's 20, 1/3 20 plus 1. And I'm going to need more paper here, so I'm going to kind of jump to the top over here. So subtracting 1 from both sides, 20 over 3 plus 1 minus 1. So, and then I'm going to divide through by what's left. So I'm going to have A equals 5 divided by cotangent of 20 over 3. All right, so let's see. 5, oh, that's right. We don't have a cotangent button on our. 1 over the cotangent is the tangent, right? So really, I just can pop this up to the top tangent, 20 over 3. All right, so 5 tangents, 20 divided by 3, and you get the same number. I got 4. So I would just eyeball that and say it's 2. So again, this was under the title of Stretch Your Mind. Play around with it. See if you can figure it out. I think 41's, yeah?
Can you punch that into the calculator? I want to check my answer, and it doesn't look the way the picture in the book.
Oh, you want me to actually, okay. All right, so what do I end up with here? I end up with, okay, so again, I don't have cotangent, so I'm going to have to say 2 divided by tangent of x plus 20 divided by 3, close paren. Oh. I'm a little scared of what this calculator is going to do. Adding plus 1 at the end. I hope he's not going to add 1 to the tangent. I hope he's going to add 1 to 2 over the tangent. But
Can you raise it up?
oh, thank you. see if that looks anything like the book. It's not bad. We could zoom in and see where does he cross the x and the y axis. I guess would be useful information. Just zoom back in.
Can you go back to your y window, please?
Okay. I will in just a second.
Oh, there you go.
There's my y. So I'm multiplying by the cotangent by dividing by the tangent. So it was a hard problem. I probably wouldn't put something quite as complex on the test just because, you know, unless it was, we have a lot of time to work on it. All right. I mean, does anyone not see how that technique would more or less apply to this? This is obviously not a cotangent. It's obviously what kind of function? Cosecant or secant. It's 1 over on the sine or cosine. And again, you have to do that same kind of, you know, how wide is this little section here, and where's the middle? I guess you can see this is around the 4, and this is around -1, except it's not quite. So they make it clear they're looking for a approximate answer anyway. So okay, anybody want to take a look at your quiz and see if there's some questions about the quiz? I was actually pretty impressed. You know, most of you did pretty well. I don't know. There's this weird stuff on it you may see. There's a number and then plus some other number. And the way I did the extra credit was very complicated, and if you really want to know what I'm asking at the break, basically for some of you who didn't do well on that same question on the previous quiz, I kind of used points we got applied to that and what was left, and we applied half of it to this as extra credit. So anyway, you can just add the two numbers together, and that's your score for this quiz.
Yeah, what two numbers there?
Well, if you have two numbers at the top, if you did the extra credit and you did it right, and it didn't all apply to the previous quiz, then you would have two numbers on it. Okay. Yes.
Computer number 42. I don't know if our current time not done 41.
Okay. Well, same kind of deal here. I'm gonna do a little more abbreviated version of this, but. I wish I could trace this. So it looks like we have, again, a little to the left of the y-axis and asymptote. And then a little to the left of 90 degrees. We have an asymptote. And we have here -1. We have something that kind of comes up like this. And then 1, 2, 3, up around 4. You see over here. Okay, so this looks to me a lot like, well, before we do this, let's find the midline here. So -1 and +4, that's 3, so 1.5 is kind of where the midline would be. And that means we've got kind of a upside down sine curve here. And it's moved over in this direction. So I've already given you my guess. This is about, what did I say, 1.5. That's our D. This is probably going to be negative a sine, right? It's just an upside down sine, except it's not a sine, right? Negative a cosecant. And then what's the period? Well, the period is going to be from here to here, that's 180. That's 1 pi. So what is B? If P equals pi equals 2 pi over B, B equals 2, I'm sorry, yeah, B equals 2, x, and then we have to subtract however many degrees you want guesses there. Plus 1.5. Ooh, plus 1.5. Does that help? I lost it. Okay. All right. Any other questions on this stuff before we go forward? I want to talk to you a little bit about the next couple weeks. So today we're going to do a little more with inverse trig functions. We're going to solve some problems in class. Thursday we're going to work on solving triangles. We're going to do some of that Thursday and then Tuesday. Following Thursday we're going to do a review for the midterm. We're also going to do, we're probably going to do some work with polar coordinates. There's going to be a midterm on that next Tuesday. So not this Tuesday, obviously, not next Tuesday, but the following Tuesday, midterm. It will cover everything we've done up through solving triangles. It won't have anything to do with polar coordinates.
So is that
We might
the
do that
17th,
Thursday.
24th, or?
Oh, you want to know the date?
Yeah.
Oh,
I was a little confused.
okay. Okay. That's up there.
Thursday the 17th.
Right. So I have to bring up my calendar. So the 17th.
Okay.
Everybody got that? February 17th.
What did you say the main subject of it would be again? The main subject of this midterm?
Everything from the first day through solving triangles, which we're going to start on Thursday.
Will you give us a practicing then? Will you give us a practicing then?
Practices. Well, I'm going to do a review. Maybe I'll provide some example problems by that a week from Thursday. Is that, I mean,
Like with my previous professors, we did basically the handout. Like if you could do this handout, then you could do the midterm.
okay, I will take that under consideration.
Okay.
I think I've done that before in high school. I mean, one thing you certainly could do, I hope you hold on to your quizzes. Really look at the quizzes, see what's on there, and then I guess it's fair to give you some example problems for the stuff we're going to do today and tomorrow.
Will there be other quizzes between now and midterm?
I'm sorry?
Will there be
No.
more quizzes between now and midterm?
No. The way this is going to work is there's going to be a midterm. There'll probably be 2 more quizzes, and then there'll be a final at the very end. So, and I'm going to drop your lowest quiz if somebody is sick. You know, you don't have to worry about that.
Will I work with you?
I'll drop your your lowest quiz, unless your lowest quiz is really good, and then I'll leave it in. Your lowest quiz has to be lower than the term of the final. It wouldn't help you, it would hurt you. Okay, any questions about that? Should we go forward? All right, again, I'm kind of doing a little review here. It's nice and big. So we have some functions, some trig functions. We have 6 of them. And I'm going to go through this pretty quick because I think you all should be aware of this. This is the sine function and the cosine. Both have domains of all the real numbers. They both have a range from -1 to 1. And of course, you should know not just how those functions look, but if we multiply them by something or add a constant, the A, B, C, D stuff, how that works. Tangent function and cotangent are both very similar. They're both defined on all reals except obviously the cotangent doesn't work where cosine is 0, and similarly the tangent doesn't work where the cosine is 0, and the cotangent isn't defined where the sine is 0. And both of them have a range of all real numbers. And then finally we have the cosecant and secant. It's really important to remember that the secant is 1 over the cosine, and the cosecant is 1 over the sine. They're similarly not defined at where the cosine and the sine are 0. The graphs, whenever you have something that becomes 0 under the denominator, you're going to get an asymptote. And then on the range on these is both the same. It's just from -infinity to -1, and then there's kind of a hole between -1 and 1, and then 1 to infinity. So those are the trigonometric functions. Right? Now, on Thursday, we started talking about the inverse trigonometric functions. There's a connection here between their domains and ranges. I'm just going to draw a little thing here. Notice that the range of the sine and cosine is the domain of the inverse sine and the inverse cosine. And the ranges are not the same, right? I mean, the domain of the sine and cosine is not the same as the range of their inverses. That's because these are periodic functions. They hit every point in their range an infinite number of times. So, you could define a truncated sine and cosine that have as their domain, this range, and then you would have a true inverse, 2 functions that are each the inverse of each other. But it's also good to know that this range here that we choose is somewhat arbitrary. One way to look at that is, I'm just going to draw a sine function here, right? So when I find the inverse of this, I just say, all right, only look between here and here, right? And you get all those values. But I could just as well have picked this, right? We choose this particular section because it's, I guess, tradition. And the same is true of the cosine and its inverse, and the tangent, and all the other functions. We have to, because they're periodic, the original functions are periodic, we have to kind of squeeze them down to get a true inverse. Okay, unlike the sine, the inverse sine, the inverse cosine, its range is 0 to pi. You know, sometimes what we call these things here, this range that we're creating, we sometimes call this the principal value of the function. If you think of the inverse as having many solutions, there's one in particular we're interested in, the principal one, usually. Okay, I think you might want to notice, back up a little. You might want to notice that there's a connection here. The range of the cosine and the range of the secant are going to be the same, and the range of the sine and the cosecant are going to be the same. That's because they're just reciprocal functions. All right. I don't really want to say too much more about this. You should be kind of aware of this when you're dealing with these. I see you speedily trying to write this all down, and you know, the circles and arrows won't be there, but you know, this document, I always put this my notes on the web, so if you want to look this up, you can look this table up there. And I don't want to switch the page before you're done. You're done? Everybody else done? Okay, I'm gonna. So now we're gonna take a more direct approach here. We're going to say, well, how do you solve some problems with these functions? All right. So the first problem I'm going to show you is very simple. What is the angle whose sine is 1/2? Right? What is the inverse sine of 1/2? And I'm going to draw a little diagram here. And everybody should be able to recognize that triangle at this point. This is a right triangle where the hypotenuse is 1 and the short leg is 1/2. So what kind of triangle is that? Yeah, it's a 30, 60, 90 triangle. So we know this value here, our principal value, is going to be 30 degrees. Right? Sure enough, that's the principal value. But it's not the only value. Right? The sine function is also 1/2 over here. What's that angle?
150.
150. All right, remember this is what we call the reference angle for 150. Right? So 150 is also a solution here. So in the case of sine, you know, you can get this by finding the complements, right? Subtracting 30 from 180. But finally, since it's periodic, you can just add 2 pi n or 360 n, and here we have this grossly complex thing here: 30 degrees plus 360 n, 150 plus 360 n, where n is an integer. So this, if I asked you, I said, here's an inverse function, give me every single solution, your answer would look something like this. If I just asked for the principal value, then you can just say, oh, that's 30 degrees. And I'll be very explicit about it. You won't get a question on a quiz or a test where you're not sure. Okay. I want you to just look at this graphically for a second. I guess I already drew this one. But this is a different way to see that 30 and 150 are going to be solutions to this, that there are 2 solutions. This is the unit circle, and as you can see, y equals a half is going to go through here twice. Anyone want to tell me, if I was doing the same thing with a cosine, what would this line that I'm interested in look like? Would it be just another horizontal line like this? Be a vertical line, right? Remember, unit circle, the x is the cosine, and the y is the sine. So y equals a half, that gives me those solutions. For cosine, it would have to be x equals something. It could be some kind of horizontal line. Another way of looking at this is, okay, here's my sine function again. And again, I have y equals a half. And you can see that it's going to cross here and here. And if I were to extend this, which I'm not going to do, you would have multiple solutions off in this direction and in the other direction. Okay, this is just a way to think about this. So, all right.
Notation you use to show that you keep going on forever?
I'm sorry?
What's the notation used?
Oh,
something about
yeah.
Yeah.
And I'm not going to be, as long as you indicate remotely what I've got here. So what I'm doing is these squiggly brackets, that means what's inside of here is a set. Here I have 30 degrees plus 360n. You can just put plus 360n, and I would know what you mean by n, the integers. Again, 150 plus 360n. And then if you want to go on and be a mathematician, you could put either a colon here, or you can put a vertical bar, saying such that n, again, here we have that funny character again, is a member of, and again, here we have a little notation. We use the kind of a fancy z. Anybody here speak German or no German? Yeah. The Z comes from the German Zahlen. Z-H-A-L-E-N. So, there are all sorts of French and German mathematicians and a lot of mathematicians from the Middle East, although you have to go back a few more centuries. So, this notation is just historical.
What does Z mean?
It means the integers. And it's usually written in this kind of fancy format. So you don't need to know that. Okay, if you just say, if I say give me all the answers and you said 30 plus 360n, 150 plus 360n, that would be perfectly fine. All right, let's do an inexact problem. They're so much easier. We just want our calculator to work right here. Okay, so what is the angle whose sine is 0.356? All right. Push the little button, sine 0.356. Enter. Well, that doesn't look good, does it? Can that be right?
Radians? Yeah, that's a radian, not the degrees.
Let's take a look. Ah, yeah, I'm in radians. That's no good. All right, let's try that again. Sine inverse 0.356. I actually, when I was doing the quiz, some people would, they had their calculator in the wrong mode, and figured out, oh, that's how they got that number. And I didn't take everything off, I gave you some credit, but you do have to know, if you're going to do a calculator problem, you do have to know how to run your calculator. Okay, so here we have, we'll just call this 2085, right? But I want more, right? So what is another solution to this?
180 minus 2025.
Yeah. That's sitting over here? Oh yeah, that's there, 159.15. It's the complement. It's not going to work that way with the cosine, remember? Right? If we have if we had some angle and I wanted the cosine, well, the other point for the cosine is going to be down here, so you could either have it negative that value or all the way around. Okay, and again here I've expressed not just those two solutions, but all possible solutions. All right, that's enough for the moment. I'm gonna pass this out and we're gonna do the first 5 problems. Okay. So, if you don't have a calculator, find a friend who does. All right, take a few minutes. Everybody have one? Any extra? Now, please, if I give you a number like negative square root of 3 over 2, well, on a quiz I would have to say exact, because otherwise I'd have to accept the answer. But right here and now, where it says, you know, the first 3 give me an exact answer. And 4 and 5, use your calculator. Actually, you might be able to give me an exact answer, 2 and 3 with your calculator. Yes, properly. Yes. Put on my okay. There actually is some, you know, maybe there's a mistake, or there's some here. So you did move those shading up to 1. Then he goes up 5 over 2, and then it goes down to 5. Let's see. It says 5. this has a period of 2 pi, right? So it's, I understand, I may agree with you when we're all done, but I just, so we go over there, there, there.
I'm not sure. I'm getting exact speed.
See, so how that one right?
So I think right here, because signs are positive and
2 pi and 2 pi. The right spot there.
it determines where it is in a positive.
No, wait, I'm sorry. This is pi. This is on yours. This is pi. Right? Pi should be here. Yes, I know. So I'm trying to figure out what I
Remember?
that's right. That's right. So I'm thinking,
Oh, negative 60. Yeah, negative 60 equals 3. Right, because you're going to. We can leave that.
yes. I think that was so. That's because one of these points is bad, right?
If you remember that one,
That's positive, that's long, it's not.
So that's kind of screwy. That's not bad. So I will,
so what's not but you need it on the sign negative, which is not the first and second.
so you would get your sum.
Angles equivalent to 60 degrees.
But that's where I got it from.
180.
All right, I'll. Are you done with this? Okay.
All right. It's an angle. It's going to be an angle.
Okay.
Right.
So these are 40, right? Yeah, if you go to -30, -40 is negative, right? Okay.
Yeah.
Yeah, it's negative 2.
Square root of 3.
What do you do wrong about
The sign is. Where would the sign be negative? Sign would be negative down there, right? This is square root
Okay,
of
so I should have cheated. Hold on.
So that would tell you
So
this
this is 90,
1
yeah,
half.
so right away
This is a
you,
60-degree angle.
this is, what is the question?
So
Square root of 3 over 2 plus 60 angle.
the other one. So yeah.
So, sign positive up here, right? So, that's these two.
all of them?
There are two values.
This is
This one, -5/3.
All
Only sign 5 is 5/3.
So tangent, it goes to slope, right? Tangent, just do.
So whatever those values are, we'll call them A and B.
And of course,
Yes.
and their value is.
Yeah, whatever. I'm just saying, whatever those two values are,
So,
just have to add
like,
by n.
there's actually multiple solutions to the sign.
Multiple values.
Anytime you have the same angle for multiple
Yeah,
equal
one plus,
find that.
which could be 0, right? Get that, and there's another value, which you left off.
But you there a negative limit to that?
You can express it either way. Negative, right?
But we have a little, there's medium, 180 or 180. So there's also
Whatever, two negative.
pi. Having two. Nowhere else. The race
How are we doing on these?
only works for tangent.
No, I wouldn't think so.
Do you understand why?
Oh, we will. I just want to give people enough time to take out their
It
answers.
doesn't work that time.
Anyone who hasn't gotten to 5 yet, raise your hand.
Only if it's
101.
Nobody hasn't gotten to 5 yet? Everybody's, oh, you have, okay. Take another minute.
Yeah, text and drawing.
We want to get this simple stuff down because the next step is a little harder. Then the final step, it gets even harder. So we want to do this in baby steps here.
Yeah, it would be 135, but
We're not doing three. To the first 4, first 5.
you have to calculator for 4.
We're going to go over how to do that. Chris. Did everybody get that? I said, oh, I should go to 5. Don't go beyond 5. Go beyond 5, you're cheating. You know what we do with cheaters.
All we do is get that.
Nothing.
Reference there.
That's not a test. All right. So everyone got this, no questions, right? The first one?
Sure.
Oh, I was kidding. Everybody really got that? Everyone knows?
I got that.
Someone tell me the answer.
240 degrees plus 360 n.
I'm sorry, say again?
240 degrees.
240 degrees plus,
360 degrees n.
okay,
And that was 300 degrees plus 360 degrees n.
yeah. Now, I didn't really say whether we should do it in degrees or radians, so let's see if we can convert here. This would be 4 thirds pi plus 2 pi n, and 300 would be 5, is that right? Plus 360 n. Okay. Everybody good at that? Good with that?
I have a potentially.
There are different possible answers, but go ahead.
As far as this notation,
Yeah.
wouldn't it be 240, comma, 240 plus 360 n? Because
I'm sorry, 240 comma?
well, this notation with plus 360 n doesn't actually include 240 or 300.
Oh, wait. Okay, let's do it step by step. So 240,
Zero can be an integer, I'm sorry.
240 plus 360 n.
Never
So,
mind. No, that was exactly.
did you forget 0 was an integer?
Yes, sir.
Oh, okay. That's all right.
Thanks.
We're students, right?
Got it.
Okay.
No, it's gonna be fine.
All right. See now, I just have to say, you're the only person I know in the class, well, Yudi kind of threw it in my face too, who I know is thinking, right? So everybody else may be thinking, but I don't know, so I'm glad. Okay. All right. Okay, how about the next one? Cosine inverse of -1. Where is the cosine
Pi.
Half pi or 180.
in? Where's the cosine? Okay, so what did you say? 180, all right, or pi, right? Plus 360
And
n.
that's the only reason for us to do that.
Pi n. Okay. Cosine
Where else would it be?
I have to like draw a little picture here for me. So the cosine is the it's the x coordinate, and this is the only place it's going to be -1, right? I mean, I can draw a line here, -1. It goes through 1 point. Okay, very good. All right, now how about tangent is 1.
45
Okay, that's one of them.
plus 60.
Yeah. Plus all the infinite others. Yeah. Sorry?
Yeah.
All right, everybody, think. Where else is
225.
225? All right, I want to draw a picture for people because see, if the sine and the cosine are both negative, then the tangent is positive, right? So we have 45 degrees or pi over 4 here, right? That's a isosceles right triangle. But even though the cosine is negative and the sine is negative here, the tangent's also going to be 1. Right? So that's our 225 or 5/4 pi. Everybody's getting good at converting, aren't they? You can convert the little ones in your head. Okay, how about sine inverse 0.777? That's just a calculator thing, right? Calculator. Let's just call that 51 degrees, all right? Make it easy for now. Not high precision here, 51 degrees. But what else? What are the other solutions? Guess we're getting sneaky, huh? We're pretty close to the break here. We'll finish these up and we'll do a break. 129, the complement. And then to each of these, add 360n. Okay. Excuse me. Finally, tangent, inverse tangent of 8.32.
About 83.
And itchy trigger finger here. 8.32. 83 degrees. Okay. Where's the other one going to be?
That's plus 90.
I mean, this is now 83 degrees, right? Well, that's what happens with a tangent. You have to kind of look. Okay, it's 270, well, whatever. It's 180 plus 80. Is that right?
263 degrees.
263 degrees.
You can also just add 180 and
Say that loud so everybody can hear.
you can also just add 180 and that way you don't need to find the other right there. Because it'll already include the app.
Well, that's how you find the other.
Oh, yeah.
Okay. We want to be careful with rules of thumb where you don't think too much. Because, I mean, it may work. Well, it should work. But when we're doing, when we're learning math, we want to think as much as possible. Make sure we're on the right track. Okay. Why don't we take a break for maybe, I'll say 7 minutes, and then I'll start at 10, and then the laggards will miss out on the good stuff.
Door open it.
So you look so tired, man. Yeah.
I can't wait for that house.
Get over there. Okay. Okay, yeah, you're on the right track. Minus 60, yes. Yes. Oh, yeah, I remember that. So do you have a question about it?
Well, that's smart, and then you don't use it right now.
So,
I like opening.
here,
I like opening
here is 543.
3 and 6.
Oh, that's new. Here it is 5. Yeah. Here to here is 540. But this is moved this way. This much here. This much here. So between the two red lines, it's like
I personally read it as this is one, this is for green. Do it different. Remember this. 45, 45.
this is 5.
No, so this is
Oh, well, so what I did there is after I find the period,
you sign all of you know the sign in there.
and
You can find every sign.
whatever B,
Every one of them.
period equals
This one doesn't matter.
180
Sign
over
on. Is
B.
one over two.
Period is
Cosine
5.
is 1 over 2 over 2 over 2. Pretty simple tangents. One of those.
So B is equal to 180 over 540.
You can find all the signs and cosines just by looking.
Third,
Because we find 30% of the opposite.
plus 90 degrees.
Maybe look at it and say, sure.
Well,
No,
our function is to the left.
how they're drawn. You just draw it every time.
This would be poorly drawn, right?
them, you only need to know
It's on this, the right side of the
figure out the rest of his modules. Pretty much.
y-axis, right? But here it goes up to this asymptote.
It looks like asymptotes, but it's not. It's just connecting dots because it doesn't just go off. It has to. But it's all in line with 84, so that's what it is.
But this is still y-axis. This is like x equals 0.
Or the very least 5 feet.
I know this is very confusing.
Oh, I'll have to go over there.
Yeah. See it. Let's say draw this.
It's not very good.
Very well. So this is cotangent.
There it is.
So if I say minus
Don't do that. It's kind of cool. This messed me up in high school.
50, move function over 50. So I can move the function over 50, or I can move the axis to the
I
left.
can put it in dot mode and it doesn't do that, but so it's faded.
This is 0.
It's
So,
also the-
Now let's say, in our example, I'm saying plus 20. That means this moves this way, right? Or the axis moves this way. That's the axis. Y, X,
But like, just get
0. So then this is the asymptote.
It's kind of,
And that's what this picture shows. The asymptote is to the left.
select one
of the
room.
axis.
so we can go kind of figuring
So
out
it's
the
going
door.
to be plus. You have to think about it a little bit. And then the last part is, you know, this is pretty hard to see.
I'm going to get a picture.
Up, like the center, right between here and here. Where's my little ruler? Oh, I'll do it again. So that's that distance. So the center. So that's where the center is. So that's this point here, which is about 1, up 1. So I know the whole thing moved up 1. So that's where that, you know, plus
That's
1.
no straw. It's where it's not gonna fall.
Okay.
This is this is what we're gonna have. This is now equals to each other.
6. Oh, this is the next section. Okay. Oh. How about we wait until the class starts? And then wait till we do this, and then ask me to do this. Right now, I have a head. I can't think. But I will give you an answer. I just,
There's two kinds of things.
I want to do that in a few minutes. Okay?
Is it hard to write? Is it one to intersection easier? Using confidence?
Yes.
And with confidence makes sense too.
I'll either state it, I'll either say 2 decimals, or 1 decimal, or no decimals, or anything you do is okay. You know, if I say what to do, then you do it. If I don't, on your own. Right? Okay. Hi. You look unfamiliar. You can, William did it earlier today. Yes.
This is mechanical.
Yes. Today, at the beginning of the class, he came in.
Like,
So, I mean, they're kind of on break for the next minute or two.
But
Want
we'll
to
always get past it.
say something new? I mean, you're kind of captive audience. Okay. All right. All right. Yes. This is the stuff that my brain is not working.
Oh, yeah.
You know which
Yeah,
section? Section 8.6. Pretty inverse.
Yeah, it's good read.
Animating and gameplay on And found you can
What's your question?
be under tangent.
Oh, you did not read the part where I said, oh, find the exact value of each expressed in the value of each calculator. Then explain what your solution means in the context of angles. Yeah, you see, I don't know what they want. I don't like this book. It's an angle. It's an angle.
Good example. You're
Way ahead. I don't know what they want.
right next to it.
It's always, you know, all this stuff, right, when they talk about slope, right? Like in these real world examples, okay, so we got here a line, an angle, a slope. You know, this is arbitrary. I mean, you know, we could be weird people and we could draw our thing this way and this thing, you know what I'm saying? It's math, it's not, you know, you can apply it, and then you can say, I think that's what they're doing, they're trying to say, yeah, this angle, and, you know, I feel very uncomfortable trying to teach math. I mean, give me an engineering class, and it's a totally different world, but this is math. I like math. I just basically with this book. Yes, yes. Yes.
Oh, I know.
Oh, yeah, the angle speed. Oh, yeah, everything, yes. Well, I mean, it won't be this problem. A problem like this, I mean, if you have three over here,
This is so good.
is 3 times 10 pi radians.
I don't even know that guy. Not kind of big guy. I don't even know.
Radius
So, no, yes.
Oh, yeah.
So it will also be omega.
You are the multi-zillion nucleus.
It's going to be in radius.
I missed it. I think you've done a lot of in my head. What? We were talking about it. Hold on.
This is 6 time radians per minute.
Now, I think this is
like 2 inches.
But that doesn't work. She's not one person. She's a nucleus of multi-nucleus. I said that in my head, I was laughing to myself. But I thought I
It's
said
not
it
that
out.
funny, except for the fact that you're laughing so hard about it.
It's funny every day.
Like, if you said that, I would have like,
No. I'm pretty
like,
sure you're like, okay, weirdo anyway.
we have more to do.
My bad.
Thank you.
Okay, so for those of you who weren't cheaters and went ahead and did the problems that, you know, I said don't do yet, 6 and 7, we want to look at this here How are we going to do these? I guess I'm going to do this trick. How are we going to do cotangent inverse? -3.8. Because we don't have cotangent, inverse cotangent, or a cotangent button. How are we going to do that? Listen carefully, and you will learn. So, let's say I'm going to take a very general approach. Let's say I want to find the inverse cotangent of x. I'm going to call y. So, if the inverse cotangent of x is y, then x is the cotangent of y. Can anyone tell me why that is?
The inverse makes the input the output, and output the input.
That's a good answer, yeah. Yeah, these are inverses. If they weren't inverses, this wouldn't work, but that's what an inverse means, right? So x is the cotangent of y, and now I'm going to take the reciprocal of both sides. So now I have 1 over x is 1 over the cotangent. 1 over the cotangent is just the tangent. All right, I'm getting to where I want to go. Now, I again switch this function. I use the inverse. I apply the inverse tangent to the tangent, and I'm going to get y. And I apply the inverse tangent to 1 over x, and I get the inverse tangent of 1 over x. Okay, so now I'm going to do a little substitution here. Cotangent inverse of x is y, and here's y, and I'm just going to get the inverse cotangent of x is the inverse tangent of 1 over x. Now, with a little, okay, everybody okay with that? That was a lot of algebra. You know, algebra is something people took years and years ago. There's a lot we can do with that. You think that through. And what this is saying is, if you have two functions that are reciprocals like this, and you have their inverse, then, now what else can we do with it? Take, for example, secant of x, secant inverse of x. What's that going to be equal to? Oh, thank you. Secant, back up a little. Secant of inverse of x, which we don't have a button for either. But we do have a button for inverse cosine, right? This is going to be the cosine inverse of 1 over x. Or we have one other one. We have the cosecant inverse of x. That's just going to be the sine inverse of 1 over x.
Wait a minute. Isn't the 1 outside of the parentheses? Outside the parentheses?
Isn't the 1 outside of the parentheses?
Yeah. Isn't it 1 over?
No, but good point. All right, let me write something different where that is the case. If I say secant of x, that's 1 over the cosine of x. This is what you're thinking, right?
Right.
But you can't just put in the -1 here. It doesn't work. Same thing, cotangent of x is 1 over tangent of x. Right? It works a little different. Again, you know, follow this through again here, right? We start with our inverse function, right, of x equals y. We apply cotangent to both sides. The cotangent I have to say this? That's like, this is so basic that maybe it's not basic. Whenever I have an inverse, or whenever I have a function, x, and I have its inverse, if I say, what's f of f inverse of x, that's x. Or if I say f inverse of f of x, that's x. Now, a couple days ago, I showed you this diagram where I made a big deal about how, 1, 2, 3, and then we have a, b, c, and then there's a function which maps this to this. So 1 goes to a, 2 goes to b, 3 goes to c, and now there's an inverse function, f inverse, c goes back to 3, b to 2, a to 1, right? And I made a whole big deal about that time about, making sure that the domains and the range, basically to have this kind of function, you have to have the same number of elements over here as over here. But look at what f of inverse of f of x does. F takes me over to a, and f inverse takes me back to 1. Same thing with 2, same thing with 3. Or I can start over on this side. A goes to 1 and then goes back. That's applying the inverse first and then the function. So, what is the square root of x squared? X, right? My function is f of x equals x plus 2. My inverse function of x is x minus 2. If I say f inverse of x, okay, well that's just x minus 2. What's f of x minus 2? X minus 2 plus 2, it's x. I hope the people who are kind of like off somewhere else are there because it's so simple and straightforward and boring. I hope so. I mean, it's a little abstract, but again, getting back here, so I find the cotangent of both sides, and I get, on the left side, the cotangent of the inverse cotangent, that's just x. Cotangent on this other side is y. I find the reciprocals, and now I have 1 over x as the tangent of y. And now I find the inverse tangent of both sides, and so here I have the inverse tangent of 1 over x. Inverse tangent of the tangent is y. Say that right. The inverse tangent of the tangent of y is y. So this tells me how I can use my calculator to solve this.
Is this true for all functions? Is this true for all trig functions?
Yes. If you line up the reciprocals, like secant and cosine, right?
So
Secant is 1 over cosine, cosecant is 1 over sine, tangent 1
So
over.
the inverse of secant would be cosine of 1 over x.
We'll get to that. We're going to get to it. All right. Let's first try and solve this one. So, here they are. So, what I really want to find here is the tangent inverse of 1 over negative 3.8. So let's go for that. So, tangent inverse, 1 divided by minus what is that? That's negative 14 degrees. Anyone know why we got negative 14? I mean, why did we get a negative number? Let me go back a few steps. Whoa. What is the range of the inverse tangent? Negative pi, right, or negative 90 to positive 90. Right. So, depending upon what we plug into the inverse tangent, you can get a negative. If you want it to be positive, you can add 360 to it, right? Okay. So now, what I'd like you to do is problem 6 and 7. You just put it away, did you? Oh, when you're done with 6 and 7, don't put it away either. Unfortunately, I'm going to need to take a break, so I'll be back in a couple minutes. Hopefully you'll be done by then. Right?
Just escalate them by talking or the back.
Yeah. Oh, you July? Am I in it? Oh, no. Yes. Then you put them in the 6 with me. So I got that too. Because they get 8 degrees though.
Oh, because you don't want to be negative, you want to be positive.
Yeah, so I get 358 points. I got this water. Believe it all day. That did not work.
You're just like really.
I know, I'm belly right now. Which one? I did wrong. What the phone?
You're not lost, are you?
What?
One over cosine, right?
Yeah.
So did 1 over inverse?
Yeah.
No, that's the 100.
Down the wall.
Your angle should be between 0 degrees and 60 degrees.
Oh. We'll have to take a look at that.
Okay, hold on.
We'll take a look at that.
Secant 1 over cosine. So that
So, I like your question.
Yeah.
Oh, wait, hold on. I know what it's
Just looking at number 6 for a second. So we want to have the cotangent.
Okay. What am I doing?
So that kind of looks like this. And this is, of course, 0 and 5, right? And we want to know what angle gives us minus 37.6. Right? 1, 2, 3, 4, 5, 6, right? All the way down here somewhere. So this is where the function crosses minus 37.6. So shouldn't the angle be close to here? Okay. So now when we were doing the same trick with sines and cosines, we had this situation where sometimes, like, you would just cross like 1 and there'd be just 1 point, but otherwise it would be 2 points and then all the periodic versions of it. Do we have that here? No, it just crosses 1, right? I mean, it'll cross here also, but that's off by the period. Ooh, oh, that 360 we were using? You gotta be careful. Yeah, it's 180 for the tangent and cotangent. Oh, and wait a minute, what if I threw a monkey wrench into this and I said, I can't really do that. I can say, what is the inverse function for tangent of 2x? This is something new. Well, tangent inverse. Well, let's find the tangent first of both sides. So the tangent of y equals 2x. Let's divide by 2. Tangent of y over 2 equals x. And now let's find inverse tangent of both sides, right? So I have the inverse tangent of the tangent of y over 2 equals tangent inverse of x. Maybe that's not what I wanted to do. Maybe. Did I find what I wanted? I wanted to find the inverse function of this. It's not really. Oh, there it is.
Ooh, no.
So if I switch x and y here, if I say, let me call this f of x. So f inverse of x is the tangent of y over 2. Yeah, that's what I want. These two are inverses, right? So if I was using this function, this function, and I wanted to know, I'm confusing myself here. Isn't that a bad thing? Let's not worry about that. Just be sure you know that when let's do number 6, right? Let's do number 6, so we don't get confused by it. So what does the calculator tell you? You have to find the inverse tangent of 1 over negative 37.6. So that's negative 6.07. Right? So there's just one of those, but
There might be a rate.
oh, you think so? Possible. Nope, it's in degrees.
Who shows that you punched it in?
Oh, I punched what it
Can you calculate it? Yeah, I think you got different numbers in those. Yeah.
Oh, wait a minute, I nobody saw, I hit 4 instead of 1. Oh, nobody saw
There
it.
you go.
They're right, okay. 1 divided by negative 37.6. Okay, negative 1.5 degrees. And it is degrees, negative 1.5. We'll just leave it at that. Okay, so, wait a minute. Oh, well, this is the cotangent? Okay, so I'm just doing a sanity check here, and this doesn't sound right to me.
You're not sounding quite think me.
Yeah, it will be 358.5 degrees. It will be, that's equal to 358.5 degrees, which we have there on the board.
No, oh. That's over here. Okay. I got a negative, I got a negative number, right? That somehow, that's over here. And I have to add not 360, I have to add 180. So it's like over here, that's 179 degrees, or 178.5 degrees. Okay, so, yeah, okay. Yes, this is very confusing. It is very confusing, but it's right. Okay, let's go back to that chart, the very beginning, and let's look closely at the range of the inverse tangent and the inverse cotangent. Okay? So we're taking an inverse cotangent, so we're thinking the principal value is between 0 and pi, or 0 and 180, right? That's what I'm saying over here. I'm looking for the value here. But how did I calculate it with the calculator? I didn't calculate an inverse cotangent. I found an inverse tangent. And the range on an inverse tangent is between negative 90 and positive 90. So it's not going to give me 178.5 degrees. It's going to give me negative 1.5 degrees. Because that's, that's where this angle fits in the range of the inverse tangent. It's up to me, if I'm going to use that other function, I'm going to use the inverse tangent instead of the inverse cotangent. It's up to me to realize, okay, this is not a principal value for the inverse cotangent. Principal value for the inverse tangent. So whoever said 180, add 180 to it, well, that was me. Someone said add 360. I would put it over here, which is okay, it's not the principal value. But I think in this problem here, this problem said, I want all of them, right? So since I want all of them, all you really have to do is add 180n. I said, give me the principal value, then you'd probably all get it wrong on the exam. Because it's confusing. Raise your hand if you completely understand what I'm talking about. Okay. It's less than half, yeah. Okay. Let's see if there's another way to... I don't think so. All right, I'll try it again. I'm going to start from scratch. Okay, here's our problem. We have a cotangent function. Right. When we do an inverse, this is the part of the cotangent we use. We don't use, these periodic versions of it. So when we do the inverse, the output is going to be between 0 and pi. All right? So when I look for negative 37.6, that's down here, and the answer is about 100 and, it's very close to pi, about 178.5 degrees. Okay, that's what we're looking for. Now, how did we go about getting this? Right? We looked at our calculator, and our calculator didn't seem to have an inverse cotangent function. Does it by any chance? Does it? Does the catalog have? You don't think so? Okay. Yeah, so there's a lesson here, which is the calculator will do the hard work for you, but you still have to be smart. For those of you who don't know about the catalog, there's hundreds of functions here. Still look for the cosine and the inverse cosine, and the hyperbolic cosine and the inverse hyperbolic cosine, but no cosecant or inverse cosecant. Sorry. So you're gonna have to think about this. So we wanted to find this point, but we couldn't use the inverse cotangent. We had to use the inverse tangent. But as far as the inverse tangent is concerned, the range, I'll just draw it this way, is from here to here. It's from negative pi over 2 to pi over 2. That's where its principal values are. This is outside of it. So it is going to give me an answer. It's going to tell me negative 1.5 degrees. And it's up to me to go, oh, that's not the principal value for the inverse cotangent. I have to get the right principal value, if that's what I was asking, I have to move it over 180 degrees. This is probably the most conceptually difficult thing I think we've run into. So if you don't get it right away, drink lots of coffee. Yes, go ahead.
So, if we're finding all the values, you said we can just use negative 5 degrees
Yeah,
plus 180.
yeah, times n. Yeah, that's correct. That would be almost a trick question for me to say, find the inverse cotangent of negative 37.6, find out, give me the principal value. Because most people would just give me negative 1.5, because that's what the calculator spewed out. You have to really strain to think, oh, it's not a principal value of a negative cotangent. Yes?
When you say principal value, you mean like the standard, right? Like quadrant 1?
No. It's, okay, all right. Here we go again. So, here we have the inverse functions, inverse trig functions, right? They all have a domain, that's pretty clear. There's no, it's the same as the range of the original function, right? But now, where do we want those to go to? Since there are multiple outputs possible to make it a function, right? In the case of the sine and in case of the sine, we make the output negative pi over 2 to pi over 2. In the case of the cosine, it's 0 to pi, right? And in the case of the tangent, it's just like inverse sine. It's negative pi over 2 to pi over 2. But the inverse cotangent is different. And we only run into trouble because we're trying to find the inverse tangent, inverse cotangent using the inverse tangent function on a calculator. We have the exact same problem with secant and cosecant, right? You're going to take an inverse to find a inverse cosecant, you're going to find an inverse sine. The inverse sine's range is different from the inverse secant's range. I got my head around this, but I've been doing this for a long time. I can understand this is pretty tricky. This is where, like, if you've been listening to that range and domain stuff and go, oh, yeah, it doesn't really matter. This is where it matters, actually. So, all right.
Wait, so I have a question on that one. So,
Okay,
so
good.
that would be the primary thing to falls outside of the range, the negative 1.5?
Negative 1.5 is not, it's not a principal value for inverse cotangent.
Okay.
But that's the number that our calculator gave us because he doesn't know we want an inverse cotangent. We asked it for an inverse tangent, right? So it's sort of the right number, except to get the principal value, you have to move it back into the range. All right. Any other questions about this?
Can you do the next problem because it's going to be similar, right? Number 7, it's going to be similar, right?
Let's give it a shot. Let's see what happens. All right? I lost my pen. Okay, so this is going to be the cosine inverse of 1 over 2.5, right? So let's see how that works out. So cosine inverse, 1 divided by 2.5. So that tells us 66 degrees approximately. All right, so the question is 66 degrees in the range of the secant inverse? Let's see. Inverse secant, 0 to pi. So sometimes you get the right answer,
No,
Sometimes you don't.
yeah,
Half the time you don't.
you have to always check it then.
Yes.
Will we be given the ranges and the domains on the exam? Or will it not matter?
Will you be given the range? You mean, will I give you this piece of information?
Yes.
If you want to jot this down on a card, that's okay with me. I'm not, you know, you should be able to, I guess right from where you are now, it doesn't seem like they would be obvious, so surely you can. I'm not going to put a table on it. So if you think this might be useful, you know, put it on a card and, you know, and you can just download it from the web, you know, if you want to take my, you know, PDF and squeeze it down, you can do that. Okay, I know there's a question somebody has on the homework, and I want to get to that, but first we have one more problem to do, which is harder than all the rest.
Number 8.
Well, we're going to do 8, but first we have to learn how to do it. So, here we go. So here's a slightly different problem. I want you to find all solutions for this equation. Sine of 3 theta equals some funny number, 0.469. But I'm only interested in solutions between 0 and 360. So I don't want to find all of them. And I have this little complicated thing here that we want to figure out what to do with that 3 theta. So let's first start with finding out what the inverse for sine, inverse sine of 0.469 is, right? So that's, I'm just, you know, truncating at some point, 27.97 degrees. Well, that's 3 theta, right? Yes?
Why do you switch to the inverse of sine or the question after the sine? Is that just an accident or is that something done on purpose?
Sine of 3 theta equals 0.469. Okay? So I'm going to find the inverse sine for both of these on both sides. Right? So the inverse sine of the sine of 3 theta is sine inverse of this, sine inverse of this. So what's the sine inverse of the sine of x? It's x. I apply a function and then its inverse, I just get the thing back. So the sine inverse of the sine of 3 theta must be 3 theta. And that's equal to the sine inverse of 0.469, which we just decided was 20. Let's make it 28 degrees. Let's make it simple and round. That's why I'm doing this, because I need this number. That's not my answer yet. If 3 theta is this, then theta is this divided by 3, or, well, I guess it turned out to be 9. Are we all following this? This is, like I said, this is the hardest problem we're going to do today, right? I want to find out what theta is, given that the sine of 3 theta is this value. If I said if the sine is, if I said the sine of x is this value, you just go, oh, find the inverse of this, right? Find the inverse of it. 27.97 degrees, or 28 degrees, or whatever. But that's not x, that's not theta, that's 3 theta. So theta is 1/3 of that. So this is degrees. So that's definitely one of my answers, right? Now the sine function is also positive in quadrant 2. So in addition to 27.97, we subtract 180, we get, what do we get when we subtract 27? It's about 152 degrees or something like that. But we don't really, that's not our answer, that's still 3 theta. So we divide by 3, and now that's our second value. Right? So I can't really do this by drawing lines the way I did it before, right? I can do this inverse sine, right? So here's my sine curve. This is 1. So 0.465 about here. So here are 2 points. Here are 2 points on the line, but I want 1/3 of them, right? So I have to take each of these angles here. Call this A1 and A2, and divide it by 3. That's my theta. Or A2 over 3. But I'm not done, because this periodic function keeps going, and here's another point. Right? Where is that point? Well, that's going to be 27.97 plus 360 degrees, right? Periodic. But again, that's 3 theta. I want to divide it by 3. So I take my 27.97, add it to 360, divide by 3, 129. Another solution. Interrupt me if you're not understanding any of this. Okay? I don't mean if you're understanding nothing of it. I mean, if there's something you're not understanding. Yes?
I don't understand how that can be 270 between 0 and 360.
Well, I'm looking for solutions that are between 0 and 360. So 9.32 is, right? 50.68 is. 129.32 is. They're all, right? They're all between 0 and 360. And we're not done yet, right? We still could take, what was that solution? 180 minus 27.97 and add 360 to that. We still on the screen here? Here we go. 180, 360 plus 180 minus 27.97 divided by 3, that's 170. So that's still less than 360, right? We can keep going. Instead of just adding 360 to 27.97, we can add twice 360. That's, right? That's this point over here, and we're going to get this point over here too. See, this is way over here. 360, 720 plus 27 is, like, this would be 787 or something like that. But if you divide it by 3, it's still less than 360, right? Oh, it's 249. So there's one more solution. And finally, the last step here. I think I did this wrong. That's okay. Oh, yeah, I need to add. This is wrong here. I don't know if the answer is wrong, but I calculated it wrong. It should be 2 times 360 plus 180 minus 270. So plus 180 minus 27.
Aren't some of these going to result in a negative answer?
All of these.
Because it doesn't need the ultimate angle.
Okay, maybe if we look at it backwards, it'll help. Each of these numbers, if I multiply by 3 and find the sign, I'll get this value.
But doesn't that mean that 3 times theta needs to be in the first and second quadrant always, though? To keep it positive.
Yes, it does. That's correct.
So it doesn't mean anything above.
Well, let's just take a look. 3 times this is 27. 3 times this is 150. 3 times this is 360.
Oh, it takes it all the way
380. Yeah, takes it all the way around. In other words, so we have some angle. Let's just plot these here. So 9 degrees, right? 50 degrees, and we'll plot one more. 129. That's over here, right? So that, I'm sorry, not 129 would be around here. So if I multiply this by 3, I'm over here. If I multiply this by 3, I'm over here. So I'm still good. I'm still in this quadrant. Now this one, this kind of goes 2, 3. It still ends up in the first quadrant. That tightening, that hit in your stomach, that's your mind realizing that math can be hard sometimes. Okay, so we're all done except for the error I might have made here. Oh, and by the way, once I get to 3 times 360 plus 27, now I get up to 369. That's outside of what I'm looking for. That's beyond 360, so I don't care anymore. So that's my set of solutions. All those different numbers. I'm not going to ask you the coincidence. Okay, if you've got, I'll answer your question, but you've got about 10 minutes. Please take a look at problem 8. It's of similar nature, except it's easier. Yes. Yep. Oh. Well, yeah, that's right. Okay, go over. That's right. I mean, you can be a little smarter than that if you divide by 3, right? So once you multiply 360 by 3 and you divide by 3, you're past 3. You're past 360. Okay. Okay. You can ask me your question again, or you can wait till it's over and ask me then. Okay, go ahead. Yeah, anyone who wants to hand in homework, go ahead. You're certainly, the homework from Thursday, you're certainly welcome to take another couple days on that since it had to do with inverse functions. But I'm not guaranteeing, I have to look at it, because it's cosine now, so maybe it's different.
Oh, see, because I got
Right. Is that the right thing to do with cosine? What was the problem again? Cosine theta equals 0.9? Okay, so 0.9 is going to be there, so divided by 2 is going to be over here. Oh, it's not. In the second quadrant, it's here, it's also going to be out there. Those will be in the first quadrant. Correct. And then you add greater than 62 and divide by 2. My 86 is the third.
Yeah, I know. So I mean, would that be like a?
360 minus 12.92. Get 33.45 and away from that equals.
Well,
Because if we times that.
what there's this one, and then this one, and then this